I don't think John quite believes that we've done it, sort of thing. That's John Bignano, not John Wallace or John Noyen. John Wallace in Victoria, John Noyen in America, John Bignano in Victoria, Southern Abertland. So I got out some of these things. I did have a straight flatbed, but can't find it at the moment. I put it aside specially, and that's probably why I can't find it. Usual Mug's Law. But I think this will do all right. And I've also got another one here. If we want to double the mass sort of thing, I know there's slight discrepancy between the carriages, I assume. But with the massive weight of, we get a massive weight of 4 of these, we can make the assumption we're doubling. If we put another mass of 4 in there, we can make the assumption that we are basically doubling the weight. But that will be for later when I build a linear track. So we're just going to prove that the linear track is going to work by Newton's third law. Yeah, we'll make use. Everyone believes in Newton's third law, so if we can show Newton's third law is operating here, we know we will be successful. But I've just got to set up the tripod. I know I'll try and clean it up, but I think it's a I'm not sure. Is it a frosted on one side? I think it's frosted on one side. I just wanted it so I could put it over some bricks, and you could see that there was nothing, nothing underneath. There's all these conspiracy theory doubters these days, so you got to try, but really, it's already going viral. People are starting to build just simple test rigs themselves and getting spectacular results, and they're going to go to this bigger version. Of course, people over in China, they're going to be making these things the size of cars. Probably by the end of the year, they'll be actually getting a program developed to actually, because they've got all the rare earth magnets, you see, so they're going to get massive. They can build massive ones of these, reinforce them with whatever they want. I don't know. Maybe you want to treat it like concrete sort of thing and just reinforce it sort of thing. So there we go. I think that's. Or should I? Hang on, I'll just do it first of all, and we'll see if we can get Newton's third law to come into play. So we got this thing on here, down there, and so there we go. I'm probably going to have to put the camera down at eye level. Yeah, quite pathetic, isn't it? Yeah. That was all the rage in 1979 here. A little bit higher up. Maybe I need to. Let's see. So I want you to see if I can get it parallel so you can actually see Newton's third law in operation. I better bring out the wheel so there's no hands on the wheel. There's all these, naysayers out there. Now, any physicist worth his salt, once he sees Newton's third law in operation, hang on. It's probably because it's got stuff on it. There we go. Bring it right down. I'll probably have to just go down faster. There we go. Do it again. So that it's reproducible. It's probably because of all this crap on the glass. But, oh, there you go. Yeah, it's going to work, fellas. I mean, that's just basically 2 units. The second one's slightly modified than what it should be because you've got to use a discriminator. And of course, when you build up your train system, probably Elon Musk will have some system where he'll flip these and the train can go the other way rather than building 2 lines. You can probably flip this over, turn that around, and have your train going back the other way, the way it came. Oh, I'm sure they can work it all out. There's people they're probably having a conference meeting tomorrow, and they've probably got a set of magnets out on the table, and they're just checking. They'll be like, bloody hell, it works, and suddenly all the the pennies are dropping in their mind. Shit, the Chinese are onto this. Fuck, they're going to be building one of these by the end of the year. We've got to get on it, But lucky enough, they've got the infrastructure to have a fighting chance of catching up with the Chinese. But you know, we're a planet, fellas, in the universe. Who cares if it's the Chinese? As long as it just bloody well works, it's going to spread out anyway. You know, I mean, what's going to be good is they're going to get rid of all their smog over in China, aren't they? Once they start building, you have to. Well, if they can build a bloody replica Bulgarian city or whatever it was, some city they replicated in China within, I think they did it in 4 months or something. So they sent people over there with cameras. They filmed this thing overseas, came back, designed it all, and it was built in 4 months. And then a bloke came over from the area, and he just it was blown away. He could hardly tell that he wasn't back home. You know, he couldn't believe he was in China. He felt like he was at home, sort of thing. So you know, maybe that's the communist way. You know. And we don't want you to leave, so, you know, if there's anything you're really itching for, we'll build it here. You want to go to Switzerland? We'll build you a small Swiss village and you can stay here and enjoy Switzerland in China. Nixon in China, yeah, I know. Funny. Anyway, so there we go. So shall we try one more? Well, let's try it with a different car. Just to show that it's not the car. Get this straight out of the box, as they say. I mean, surely John can build him one and build himself. You know, go down the shop, get a whole pallet load of magnets, and be in the shed this weekend building himself something. Well, there you go. Newton's third law. To every reaction, there's an equal and opposite reaction, because we discovered that we can actually get this reaction using. There we go. Whoops. There you go. So we can actually get this reaction at 90 degrees using the gyroscopic nature of matter, of course. Put it down. So the next build is going to be a linear track, but Mr. Motion magnets can do that. I don't really want Mr. Motion magnets, but if John doesn't quite believe me, I'm going to have to do it, aren't I? So yeah, and then we can do Newton's second law. F equals ma, and double the mass, and so on and so forth. Okay. If the force stays the same and you double the mass, how much does the acceleration change by? Okay, F equals ma. Yeah, Newton's 3 laws. The first one, the law of inertia, but it's very long-winded. It just talks about rest and motion. It doesn't really talk about the going from one to the other. F equals ma, which is the second law, and to every reaction there's an equal and opposite reaction, which is the third law. But my favourite is the first one, because it's so long-winded. You can see, you know, like if you're out in space and you're trying to push a big asteroid, you're actually internal to the asteroid, you're not actually external. He's really thought about it quite deeply, and probably had some of the first beginnings of relativistic